All right, so my name is James MacAulay, and lately I've been thinking a lot about promises. Promises have a long and storied history. A few years ago, there were various libraries which were starting to converge on a common way of managing asynchronous processes in JavaScript. Eventually, a standard emerged. Then a better standard took its place. This is Dominic Denicola, one of the people who was instrumental in developing the Promises A+ standard. Him, along with a bunch of other people, put a lot of effort into this. And in late 2013, that standard was incorporated into the ES6 draft specification and was implemented in browsers. So this is what you get when you type promise into Chrome's JavaScript console today. This is great. We now have a single full-featured promise API that we can rely on going forward. And because promises don't require any new syntax or language features, this new API can easily be polyfilled for older browsers. OK, so let's take a step back and talk about the good old days before promises came along. This is a typical asynchronous function call. We're getting something from the server, poking at the DOM. We have a function getAsync. It's going to fetch something for us. We pass it the URL to fetch and a handler function, which will do something with the retrieved data. And the return value of the getAsync function is undefined. We really just don't even care what the return value is. What could it possibly do for us? The process is asynchronous. We don't have the results yet. So time passes, the event loop ticks away. And eventually, at some point, our handler function gets called. It gets called with data from the server as its argument. And we have some code in there which pokes at the DOM. Again, our handler function returns undefined. We don't even think about that, because what would it possibly do? Here's the code again. Now let's look at the same behavior implemented with promises. Here's what the code looks like. It's really not much different. We've got a get function. We pass it the URL. This time, it immediately returns a promise object. You can perhaps imagine the hand signing a contract. So we have this promise object, and we have a then method on the promise, which we pass a handler to. It's a handler just like before, does the same thing. It gets, just like before, time will pass, and the handler function will eventually get called with data from the server. But before we get to that point, we actually get a new promise back as the return value of the then method. But because we're still focused on poking at the DOM, we just don't care about that second promise at all, at least in this example. So what's the point? It's a good question. Here's the most important thing about promises. Promises are returned from functions. You get an actual value back right now, and that value means something specific. The second most important thing about promises is that the then method always returns a brand new promise. And the resolved value of this new promise comes from the return value of the handler you passed in. So here's an example from the README of the popular promise library RSVP, which is used in Ember, showing how we can chain promises together in a useful way. First, we get a post from the server. Then we use the comment URL from that post to make another request for the post's comments. Notice that the return value of the first handler is itself a promise. Actually, this is really, if you're chaining things together like this, this is a really powerful thing you can do. Thankfully, when you return a promise from one of these handler functions, it ends up getting collapsed into the promise returned by the then call. So what this means is that the second handler function, which takes comments, actually gets comments instead of just a promise for comments. One other thing to notice is that the catch method there. The catch method handles errors, and it handles errors that may have occurred at any point along in the process. Already by the time it would get to the catch function, it would have gone through a few runs of the event loop, at least. And we can now say goodbye to callback hell. So this is great. The error handling is really nice, and we don't have to nest our callbacks like we do with traditional async in JavaScript. But we really haven't gained all that much. Instead of our code drifting to the right, it dribbles down the screen. The error handling is probably the biggest win at this point. Instead of having to thread our errors through each level of nested callbacks, we can keep our error handling logic in one place. And this is closer to the way we're used to handling errors in our synchronous code, where errors will just bubble up until you catch them. So this is nice, but is it really worth introducing a whole new API into the language for the sake of this? I'm not sold, at least with what we've seen so far. OK, so let's get into something a little more meaty. Here's an example of a test assertion using the chai test assertion library. This is pretty readable. I think even if you're not familiar with the library, you can see what's going on. What if we want to test our asynchronous code? How many people here have tested asynchronous code in JavaScript before? OK, so it is, as you probably know, notoriously awful to test asynchronous code in JavaScript. You need to basically be always keeping track of a function which you have to call at the end of the process of testing, which will tell the test framework that you're done testing. And if you have multiple callbacks, then you need to probably keep a counter of how many callbacks you've done, and yada, 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 yada. It just explodes into a bunch of complexity. So with the help of two different libraries that work really well together, we can actually do asynchronous testing really nicely. This uses a library called Mocha as promised and a library called Chai as promised. And I think this is really a good example of promises being taken seriously in your test suite. This is a joy to work with. Here's where the magic is. Right here, it's the fact that getCount returns a value that can be passed to other functions. And it's the fact that the test framework knows how to treat promises almost the same as any other value. I say almost the same because you do need to stick that eventually there. I think it's a fine design decision to say that you need to be specific here, that you aren't just going to that you're actually going to care that the result is a promise in this case. I think that's good. Here's a very simple Ember app. We have basically a single route. It has a model function. The model function returns an array of users or something. Now, probably when you go to a route, in a lot of cases, maybe most cases, you want to get your models from the server, or maybe they're cached or whatever, but there's probably some asynchronous stuff going on. So Ember lets us return a promise from the model function, like this. So this is still a very contrived example. Promise.resolve is built into the native promise library, and it just takes a regular value and returns a promise which will immediately resolve to that value, although in the next run of the event loop. We don't need to do anything special here. We can return a promise from this function just as easily as any other value. And importantly, Ember knows to wait until the promise resolves before it will render the view. This is a more realistic model function using Ember's data store to fetch model data from the server. It works so well because the data store's find method returns a promise. It's a promise that you can use like any other. It has the same promise API as that's promises A+ compliant. So everything works really well with the rest of your code that might take advantage of the benefits of promises. Ember also has a really great Chrome extension that lets you visualize whatever active promises there are in the routing system. Overall, Ember's use of promises is really nice. But outside of a routes model function, there are very few situations in an Ember app where you can use promises interchangeably with other values. For example, you need to jump through a lot of hoops in order to get something that's kind of like computed functions, computed properties, rather, that return promises. So the promise of promises was that we could work with composable values, whether or not those values needed to be computed asynchronously. So how can we build systems that deliver on that promise? We need to start small. This code uses the when.js library. We have an array that includes both promise and non-promise values. We use the special when.map function to get a list of names. It works just like a regular map function, except it is agnostic about promises. And it always returns a promise of its result. So the function, the anonymous function that we pass it, can be assured by the semantics of when.map that, that the t value is going to be an actual resolved value, not just a promise. I call functions like this promise agnostic. They don't care if their inputs are promises or not. When.js has tons of functions for juggling promises. This library has been taking promises seriously for years. When.js is great. However, it's coupled to its own implementation of promises. It predates by a long shot, the promises spec even, I think. I think it predates maybe even promises A, the first spec. It influenced those specifications. So it's gotten to be a sizable library with its own promise implementation. But now that promises are part of the language, we can have smaller, more composable libraries that don't need to reinvent the wheel. In fact, we don't even need to couple together the behavior of being promise agnostic with the particular implementations of these basic functions. Let me show you what I mean. Here's the toolkit that we're going to work with. Here's a function called when. It's basically actually works the same way as the when function in when.js. It lets us take any value, whether or not it's a promise. It casts it as a promise. Promise.cast is built into into Chrome now, and Opera and Firefox Nightly, I think. So it's part of that draft specification. So it casts the first value as a promise, and then it calls the then method on that promise with the given handlers. So really, this is just a way of it's like a way of calling then on anything. Here's another function that we're going to use, promise.all. It's a native function, it's part of the spec, which takes an array that might contain promises and returns a promise which resolves to an array of all the resolved values. So in the previous example, we had an array with name foo and another one with a promise of name bar. Well, if we did promise.all and passed it that array, we would get back a promise which resolves to an array of just name foo, name bar, with no promises in it. This is an important primitive construct because it lets us take a bunch of promises and just settle everything before we do work with it. With the help of promise.all, it's straightforward to write a similar function, all object values, which works on objects that might have promises as values, returning a promise of a fully resolved object. So this is just like promise.all, but you pass in an object, it might have promise values, you get back a promise of a fully resolved object. Okay, so now things start to get a little juicy. Here's a wrapper function, which makes any single argument function promise agnostic. You pass it in a function, it returns a new function, which takes an argument and returns the value of when, called with that argument, with the original function that you called. So it's probably pretty hard to follow at this point. Basically, this this lets you wrap a function in a way that makes it agnostic in terms of a single argument. Here it is wrapping underscores size function. So the size function simply gives you the length of an array. Or maybe also the number of keys in an object, I'm not sure. The resulting agnostic size function that we have here can now take a promise of an array and it returns a promise of that array's size. So that size promise would resolve to 2 or whatever. Of course, most interesting functions take more than one argument, and many functions are actually methods which act on a receiver, aka this. So really, if we want to have a more generic wrapping function, which works on not just single argument functions, we need to wrap it in such a way that we concatenate this, the receiver, with the arguments to get a flat array of the inputs of the function. We can group together this and the arguments to talk about them generically as inputs to the function. We call promise.all on that array. We wait for the resulting promise to resolve. And then we destructure the inputs array back into this and arguments and apply the original function to them. And at the end, we get a promise back. So this is a simplified version of the code. It reads like just what I said, basically. We're composing together a bunch of these wrapper functions, and they do different things to the data. Gather the inputs, transform the argument with promise.all, wait for the argument, and then spread the inputs again. Here's the actual code in the library that I'm writing right now, which is exploring these ideas. It's not much more complicated. It's the biggest difference is that this is actually a factory to create different kinds of wrapper functions. You can do that by configuring the particular flavor of agnosticism depending on your needs. Yeah, okay, so for example, any function that performs operations on the contents of an array, for example, map. If we want to make an agnostic version of map, like the kind that when.js includes, we need a kind of agnostic wrapper which is going to look into that array to see if there are any promises inside. We don't just want our new map function to be agnostic about promises of arrays. It should also be agnostic about arrays of promises. But we need to go deeper. What about higher order functions, like compose? Compose takes in a bunch of functions and returns a composition of them so that it strings together the input of one into the return value of the next and so forth. Or I did that backwards. Anyway. So we shouldn't have to care about what a function does with its inputs or what kind of return value it has. We need a function that infects other functions with its agnosticism. So we need to be aggressively agnostic. This is like, conceptually this is very similar to the function we had before, which just waited for a single input. But what this function does is it wraps functions recursively. So in the case of compose, it would actually make compose, it would see that the inputs are all functions, and it would make all of those functions aggressively agnostic as well. And for any arguments that aren't functions, it would look at all elements of an array to see if they are promises. And it would look at all the values of an object to see if they are promises. And it would gather everything together and wait for everything that needs to be waited for. You might be wondering what you can do with all of this. In the example of Ember, I mentioned that you can't return promises from computed properties and have it mean anything. if your property code is such that you are making a composition of different behaviors, and you get in a promise as a return value, then you can deal with promises transparently. You can have middleware systems which work a lot like rack in the Ruby world, which compose together middleware functions, which each of them could either return promises or regular values, might even return a promise which is a collection of other promises. And you'd be able to write more and more of your code in a way that treats asynchronous and synchronous processes in the same way. So that's really the goal of the code that I'm writing right now, is being able to write the asynchronous and synchronous code more in the same way and not have to worry about it so much. So the library that I'm writing is called Kozu. I'm James MacAulay on Twitter. I work for Shopify, and that's all I have.